Good morning, ladies and gentlemen. My pleasure to be here. Today I wanted to offer some insights into the aspects of regulatory compliance of the elements, components of smoke control systems. In that aspect, we'll be looking into environment of the regulations that are present here, the aspects of the labeling that is put on the products and the information they contain, as well as some of the, let's say, challenges, observations we made over the course of time, some misconceptions that it's really important to deal with to make sure how to address them. Let me start with the idea of what is being prescribed. I think there's no need to introduce the set of Saudi codes that are present here to the audience here, with the building code, mechanical code, and of course leading fire code, Saudi fire code, that requires some of the fire life safety systems to be included in the buildings. And this applies equally to the smoke control systems that can be divided into smoke containment, that is constructed and used in the buildings to prevent the spread of smoke. And usually it relies on the concept of pressurization, so creating the pressure difference between the compartments, as well as the aspect of smoke management, managing the movement that can be done mechanically through mechanical exhaust, or using the natural forces of thermal uplift and gravity ventilation of the heat. To be able, so I want to offer different perspective on the legal aspects of the use and of the challenges in the implementing those systems in the building. And when you look at it, we are not able to build those systems without the access to the products, the components that were legally introduced to the market, placed on the market. And if you would like to get more details about what's applicable, not only to those systems, but to all systems in fire life safety, the interesting information can be found in Saudi product safety portal called Saber, in which the product manufacturers and importers are obliged to register their products prior to introducing them to the market. When we will research and look up for the information on the smoke control systems, we get the feedback from that portal that there is a SASO technical regulation for general requirements for machinery safety. And when reviewing the information inside, we really can't find any details regarding smoke control systems. So the idea, we put the information, the regulation comes, studying it, we can't find this information. I believe it deals with the aspects that regulation is focusing on general safety and may deal with the smoke control when it comes to removing of the results of the process of combustion, either from kitchens or from, let's say, some combustion engines, general aspects of smoke control, but not dedicated to fire ventilation. Does it mean that the specifiers and consultants are helpless? Let's first focus on what are the key elements of smoke control systems that really require our attention. And these would be fire-rated powered ventilators, fire-rated duct systems, and dampers to deal with smoke and sometimes would require to have the fire resistance performance. Draft curtains, similarly, will be dealing with the aspects of preventing spreading of the smoke, but may also be having the performance associated with fire resistance. Natural smoke and heat ventilators to release the accumulated smoke and heat in the buildings. Pressurization systems that will be facilitating the smoke containment systems implementation, and control panels. And I wanted to provide the information as, I would say, user-friendly manner as possible, knowing that there is no technical regulation. But on the other hand, the specifiers and purchasers need to address this subject. I've prepared a table in which those products were listed, and we will try to find or analyze different sources of information to see if there are some indications, what standards, what requirements can be applied. So starting with the Saudi codes, the Saudi fire code, we can find a reference there for natural smoke and heat vents That's leading to two types of standards. There is underwriter laboratory standard and factory mutual standard that is prescribed by the Saudi fire code, as well as the control panels. I think it's hidden behind the chairs, but there is a standard named UL 864. So this is the perspective of the Saudi codes. 2 out of the listed groups is there. Moving further, Saudi codes for the smoke control systems are referring to the design standard, NFPA 92. In that standard, we can find a reference for dampers. Smoke damper alone, UL 555S, or combination of smoke and fire damper, where the fire resistance would be required from such product that relies on the combination of UL 555 and UL 555S standard. And as you see, based on the, let's say, regulatory perspective, these are the fields that can be spaces that can be filled in with the information. So let's have a look at the information that can be found in the catalog of published standards, but by the nationally operating standard development organization, the SASO. In their catalog, we can find all the missing points to be filled in with the ISO originated standards from the family of 21927 with different parts dedicated to different components or systems, and with UL 555S standard also incorporated as a SASO standard. But this is not the end of the full picture, because there is also the information I've collated before preparing that presentation, that is resulting from the conversations we had with manufacturers, with those inquiries that are coming with the request for certification activities to be offered, and in the public domain. And I think this is also in this list, in that part that I called alternatives. These are the standards that are issued by other standard development organizations. You may find some of them that you may see in the everyday practice when dealing with smoke control systems. You can find there for other product categories, UL standards, BS standard for duct systems, as well as for draft curtains, and the family of EN standards, 12101 series of standards. Few takeaways and conclusions at that stage. With that list, it means specifiers, purchasers, consultants are not helpless. Yeah, there is a reference, technical reference, to make sure that the product is, I can call it, in general, product is performant. Yeah, it will serve the purpose. It's fit for purpose when it comes to the incorporation into smoke control system. Another insight is that the ISO standards and EN standards are, what to say, almost the same, similar. The text of these two is similar, and historically, EN standards were developed and they were adopted by ISO organization, and then further adopted by SAS organization. So I believe there is, with this table, there is a fantastic ground for potential future development with respect to technical regulation for these products. The only aspect that is missing now is what type of the certification should be applied. But this, I will return to this topic and will try to give the answer, and the time when we'll be analyzing the equipment label. Then I wanted to move on to the aspect of the information that will be expected to be seen on the labels that will be put on those products expected to use in smoke control systems. And I will start with the first part, quite self-explanatory. We are expecting the product name and type. By type, I mean model, so like unique identification of what we are dealing with, just to make sure that we are having the proper reference when speaking to the product manufacturer, and also the details of the manufacturer, which can include the name or the brand or logo. Most important, there should be a party we are communicating with in case there are some challenges or questions, or maybe the complaints regarding the product performance. Then, if the manufacturer completes the certification process, there will be this display of compliance, of conformity with the standard that was applied, and you may be already familiar with the marks I'm presenting here, like the Underwriters Laboratory logo with additional information about the product listing or approval, factory mutual approval, or since a few years ESL certification mark, or any other marks. The aspect of, let's say, lack of technical regulation means that the responsibility for confirming what type of certification is considered for the purchase process is on the purchaser. So in other words, the aspects of whether the product was properly tested, the factory was inspected, and if the continual surveillance over the manufacturer is implemented, is to be confirmed by the purchaser, unfortunately, because it's not yet prescribed by the local regulations. And of course, the fact of the product being certified should refer to the certification number, and in the certificate that is issued, the reference to the standards that I've already presented should be included. Only then we can say that there is a full picture of the compliance presented on the product. And last aspect is the actual performance. Yes, we are expecting to see the information, the outcomes of the certification, what has been confirmed. For the scope of this will differ for different product categories. The most important information from my side is when you know the specific standard is applied and there are some essential characteristics required by the standard, expect them to be presented in the label, on the label. So it will include for those products that are having fire rating, to have this fire rating explained, presented, together with end-use application. There are some situations in which the performance is directly linked to specific end use and may not necessarily apply to other end users. So now coming with a few practical examples that we've seen in the past. First one, what are the statements that you can see? And for this, you will see the majority will be referring to the duct systems, because they are somehow, I would say, the colorful example in which we are finding interesting information that are being discussed and presented to the market. First one, that the rating up to 120 minutes. With the expression up to, it already suggests that it's not uniform for all the categories and users. So we have up to 120 of stability, integrity, insulation, which means one of these parameters may have the other reading, as well as for the end-use application for ventilation, smoke control, or kitchen extract, it may differ. And practical explanation. This is a picture representing, photograph representing the duct after completion of the fire resistance test in a furnace. You can see there that the profile, like the duct remained in place, didn't collapse, didn't show any signs of cracks. However, its rectangular shape got modified. Yeah, there was the cross section of the duct got significantly reduced, which means it will prevent the proper transportation of the smoke if it's used for smoke exhaust. In that case, if the duct was tested for 120 minutes, this aspect of smoke control might have failed before. My suggestion, always ask for specific, in case of such general statements, ask for very specific information. What is the rating for ventilation use? What is the rating for smoke control use or for kitchen extract? Similarly, manufacturers, there is, I would say, the market practice by the certification bodies, whenever the system does not deliver rating for all three parameters of stability, integrity, insulation, is to keep insulation isolated. In our practice, we do the same. Whenever 120 minutes was not achieved, but the insulation failed before, insulation is presented before. However, I'm asking myself the practical question: if you're planning to utilize that duct system to penetrate the partition wall or a firewall that is rated for 90 minutes, will you be able to use that duct system? To me, no, because even though the stability integrity is ensured, insulation fails after 60 minutes, which means from 60 to 90, there is a risk that fire can spread to another compartment, and the whole idea of compartmentalization is affected. Another challenge, and I would say it's very specific to the tests that are done for the ducts, conducted for the duct systems, is that the duct need to be prepared either to be attacked by the fire from the outside, or in a case it developed in a place from which the heat and smoke will be extracted, the heat will be attacking the duct inside. And there are two separate tests done for each type of the duct to prove that it's equally resistant for the specified time from the outside and from the inside. However, you can come across some situations in which ductwork was tested with one configuration for one fire scenario and the other configuration for the second fire scenario. And then demand of using this as a proof that such system can be used. Practical example, when there will be different number of layers, insulation layers on the product. Yeah, one scenario 2 layers, another 3 layers. It means I am having 2 different types of ducts tested to one scenario only. Keep it in mind whenever you will come across such situation. Then components of the ductwork systems. Some of them are like access panels, volume control dampers, or maybe compensators for thermal compensation, thermal expansion. If you are facing the situation in which those components are implemented in the actual project or designed to be implemented in the actual project, make sure that these components were present when these duct systems were tested, and they are mentioned in a certificate based on which the decision is taken to apply them. Why? First thing, if the element was not included and was incorporated in the ductwork, this situation may render the certificate null and void. A certification body will be able to say, sorry, I was not aware that such construction is going to be implemented on site. It was not tested, and I can't really express my opinion whether it is or it is not conforming to the standard without really testing it. Similar situation applies to penetration seals. We became aware of the practice, which sounds, I would say, logical, that ductwork manufacturers bringing their ductwork, installing on site, but leaving the aspect of the installation of fire stopping to the fire stopping contractor. But you know, specifically for penetration seals, they are not tested separately. They are tested always with the ductwork, with the system, and they are linked to that system. So whenever the duct is being installed, there need to be assurance provided that also the system of sealing the duct in a fire-rated wall or construction is also following the requirements that were included in this product certificate. And some of the aspects you might have come across that situation when market was offered with the so-called low temperature ducts, that they were testing to the lower value of the temperature. Explaining it practically, when we are seeing fire-rated duct, we expect that at the 30th minute it was already subjected to the temperature of 800 degrees, and at the 19th minute it will be more than 1000. But in that case of low temperature ducts, the temperature increased during the test, stopped at 400 and just remained there. And the duct was proved to just follow that, to meet that requirement. Maybe it can be used for some of the, let's say, design, if there is such objective for the construction, for the ventilation construction, but definitely not for naming or claiming that such construction is fire rated. And also recent, I would say, communication that we became aware, there were some attempts to use the insulation material for ducts that is already containing some cancerogenic substances. That situation may be motivated some financially, that this type of materials might be cheaper, but on the other hand, think about practical implications. Testing can be done, will require more measures to be applied at that stage, more, I would say, cleaning process after that stage, and assurance that people are not taking proper measures. But imagine also handling, installing, making sure that it can be properly maintained on site. There would be additional costs involving that, even if it's not restricted by the law, and at some point it might be restricted and may be requested to be removed from the buildings. And last aspect, when you saw in the table I've presented, with reference to pressure differential systems, codes, standards, NFP 92 was not offering any technical requirements for such systems. Why? Because they are fully engineered on site. There are specific parameters required from those systems on site that need to be proved at the commissioning handover stage. So there is little testing laboratories or certification bodies can help, but there is an alternative for type testing of kits of pressure differential systems. Coming from Europe, there is EN 1211 Part 6 standard. I wanted to share that information with you if you are dealing with such systems and would like to see that some of the parameters of, let's call it not full system, this can't be tested, but sub-assemblies of the system to be pre-tested and certified. And then such components, knowing their performance, introduced to the building, there are higher chances that at the stage of the commissioning, the system will be achieving its functional objectives. That's all from my side. Presentation was relatively fast, just to make sure, just to comply with the time limit that was expected, to be delivered. However, I'm open to either elaborate on those topics that were presented, or to learn from you if you have some additional insights with respect to smoke control systems. I'll be there in the networking sessions, and please don't hesitate, just approach, and I'm really happy to discuss it further. Thank you.